This is a video about kinetic friction. We haven't started talking about friction before very recently, so this is going to be a little bit different. Here's what we have. Friction is a force between two surfaces. When you take chemistry, when you take general chemistry, you start talking about intermolecular forces, and it feels like the answer that just kind of fits for pretty much any question. Why does this happen? Why does that happen? It's intermolecular forces. Why does friction happen? It's intermolecular forces. What we have is we have some kind of a surface like this. Maybe this is a box, and then it's moving on the ground. Now those surfaces are made of atoms and molecules, so we've got all kinds of things going on here. It's not really a straight line, right? There's just all kinds of things. And same thing down here. This is all atoms, molecules, whatever. This atom over here sees this molecule over here, and there is some kind of an attraction between them, right? They shift their electron clouds. There's some kind of an electrostatic attraction between them, and so they want to hold on to each other. If this whole block is sliding to the right, well, when these two try to hold on to each other, that's going to slow the block down a little bit. And then when this one and this one see each other and they try to hold on, that's going to slow the block down a little bit. And we end up with this frictional force. That's where friction comes from. So let's see what we do with this. Friction we generally write as a lowercase f. It's a force, but friction, not sure why. And for kinetic friction, we're going to write it with a subscript of k. Kinetic friction is equal to mu times a normal force, and I want to talk about this a little bit. This is a Greek letter mu, lowercase. This thing is called a coefficient of, in this case, kinetic friction. It is a unitless quantity, so 0.3, 0.8, not 2.5 newtons or something like that. It's a unitless quantity. Friction is a force, so this thing has units of newtons, and the normal force, that has units of newtons, so this thing has to be unitless anyway, if we're going to make that work. The coefficient of friction is a measure of how much two surfaces want to hold on to each other. Example, if I have a rubber eraser and I drag that across a wooden table, that's pretty friction-y. How's that for a science word? It's pretty friction-y. I try and push that thing and it's pretty grippy. If I have an ice cube and I push it on a glass table, that's not very friction-y. That's pretty slippery. The ice cube and table will have a low coefficient of friction, where the rubber on wood will have a high coefficient of friction. The coefficient of friction tends to be usually between 0 and 1, but it's not a hard and fast rule. It's possible to have bigger coefficients of friction. It's not possible to have smaller coefficients of friction. It is possible to have bigger, but for the vast majority of cases that you will find, I would even be willing to bet for every situation that you will ever actually come across outside of a controlled, highly synthesized situation in a lab, you're going to end up with a coefficient of friction that's going to be between 0 and 1. What we do with this is a kinetic friction. Kinetic means movement. So a kinetic friction means this block is already moving. I've got an object like a block. It's moving on the ground this way. Because it's moving to the right, it's going to feel a friction force to the left. If this stops moving, then there's no more kinetic friction. We can't have kinetic friction if there's no kineticness going on, if there's no movement going on. So we get a frictional force. The force exists at the point where the surfaces meet, like along that surface. We talked about how in this physics course especially, we had to have contact between two items to be able to exert a force, two objects. To be able to exert a force, the ground is going to exert a normal force upward, and it's also going to exert a frictional force to the left along that surface. That coefficient of friction is something that depends on, as I was saying, on the surface, but it depends on the relative items. So a rubber eraser on a wooden surface is going to have one coefficient of friction. The same rubber eraser on a glass surface is going to have a different coefficient of friction. An ice cube on a wooden surface is going to have one coefficient of friction. An ice cube on a glass surface is going to have another. Any kind of combination, what we need is what both objects are made of, what both surfaces are made of. That's what's going to factor into that coefficient of friction. The kinetic friction is always just pointed in the opposite direction of motion. If I am moving up a ramp, so if I've got a box that's moving up a ramp this way, then I'm going to have a friction force that points down the ramp. Just always the opposite direction of the motion that's going on. And that's kinetic friction.